Hi, I'm Mallett, and the topic for this video is how pH plays an important role in the analysis of water, particularly in swimming pools. I want to start off with stating what pH is. pH stands for the power of hydrogen. It is a measure of the acidity or basicity of a certain solution. It is a unit of measurement showing the concentration of a hydrogen ion in the liquid. The pH scale ranges from 0 to 14.0, and the middle mark, being 7.0, is neutral. Any lower, and the solution is considered an acid. Any higher, and it is considered a base. The pH scale is the measure of the concentration. How it works is the P means the negative logarithm of, and the H is the concentration of hydrogen ions. So if you take pure water as an example, the concentration is about 1.0 times 10 to the negative 7 moles per liter, or 0.000001 moles per liter, which calculates to a pH of 7.0. The strongest acids have a concentration of 1.0 times 10 to the 0 moles per liter, or 1 mole per liter, which in turn calculates to a pH of 0. And it's the same for bases. A base with a concentration of 1.0 times 10 to the negative 14 moles per liter, or 0.0000000000001, translates to a pH of 14. The ideal pH of a pool is about 7.2, which means the concentration of hydrogen ions should be around 0.63 times 10 to the negative 7 moles per liter. Well, obviously none of us want to be swimming in a high acidity or basicity, as the repercussions may be fairly serious. So, the analysis of pool water for safety is the key. There are two main natural factors that affect the pH of swimming pools: rainwater and temperature. Rainwater typically has a pH of around 5.0 to 5.6. This, when added to a swimming pool with a pH of 7.2, will lower the pH slightly. Temperature is a little more complicated. pH is all about the concentration of dissociated hydrogen ions, and the reaction of dissociating water is an endothermic reaction. Therefore, when heat is added to the water, the dissociation is helped along. This leads to a higher concentration of hydrogen ions. Because of the aforementioned negative logarithm, this will lower the pH, making it more acidic. In simple terms, when the pool water is heated, the pH goes down, and vice versa. There are two ways to test the pH in swimming pools. The first involves this little paper strip with small fabric pads impregnated with a pH indicator on the top one. What you do with this is you dip it 1 to 2 feet into the water. Once you take it out, you compare it with the corresponding scale on the back of the bottle. As we've learned in class, the darker the felt pad, the higher the concentration. And since pH measures the concentration of the hydrogen ion, the darker the felt pad, the higher the pH. The second way of measuring the pH in a pool involves a chemical called phenolsulfonphthalate, or phenol red for short. What you do with this is you dip your tubes, again 1 to 2 feet into the water, and get a sample of water. You then empty it out to the marked line on the tube and put approximately 5 drops of the phenol red into your solution. Once you've done that, you can put the cap on and give it a little shake. With this one, you also compare to the scale beside it. In this second example, I mentioned the chemical called phenol red, or phenolsulfonphthalate. The chemical formula for this is C19H14 O5S. As you may have recognized, this is quite close to phenolphthalein, which we've been using in class. Phenolphthalein actually has a formula of C20H14O4, so phenol red has one extra oxygen and one sulfur. What phenol red is mainly used for is swimming pools, because it measures from the pH range of 6.8 to approximately 8.2, while phenolphthalein measures from 8.2 to 10.0. If so happens that the pH of your pool is too high or too low, there are products called pH- and pH+. pH- is actually sodium bisulfate, which will in return lower the pH of your pool, making it more acidic or less basic. pH+ is granular sodium carbonate, which, as you can tell by the name, will raise the pH of your pool to more basic or less acidic. Both are white powdered substances that will dissolve into the pool cleanly. So here we have all the pool testing materials in one place, up close and personal. First we'll start with the pH testing method number 1. As you can see, the 4 fabric pads on the paper strip, with the top pink one being the one with the pH indicator, and the scale with, again, the top one being the pH scale. This is the pool pH testing kit number 2. The yellow bottle, the orthotolidine, is used to test for chlorine, while the red bottle, the phenol red or phenolsulfonphthalein, is used to test for pH. As you can see, the 2 tubes with the 2 scales that are used to measure the pH and the chlorine respectively. Next is the pH+. As you can see, this is granular sodium carbonate. It's a white powder that is completely soluble in water. And finally we have the pH-, which is also a white powder that is completely soluble in water, but this is sodium bisulfate. So what are the repercussions of low or high pH? If the pH is too low, the following may occur: scale or calcium buildup on pool surfaces at the waterline or on accessories, cloudy pool water, a clogging of the filter, and for swimmers, a burning sensation in the eyes and nose, and or dry or itchy skin and scalp. If the pH is too high, then there may be an eroding in the pool lining, corroding of metal pool accessories, staining from metal corrosion. The chlorine may rapidly dissipate, which requires an increased dosage, burning, and again a burning sensation in the eyes and nose, a dry and itchy skin and scalp, and damage to swimwear, pool toys, and accessories. As I mentioned before, the indicator used in pH testing is phenolsulfonphthalein. A phthalein is any range of lactones formed by the reaction of phenol with phthalic anhydride. A lactone is a cyclic ring-shaped intramolecular structure derived from a hydroxyl acid. A phenol has the formula C6H5OH, which is derived from benzene, C6H6, just with an extra oxygen. And phthalic anhydride is the acid anhydride of phthalic acid. In conclusion, pH plays an extraordinarily important role in the testing of pool water. Without pH testing, there would be no way of testing the acidity of pools we have today. All pools would be subject to the natural elements that affect pH, and there would be nothing we could do to change that. pH is used in the testing for the safety and cleanliness of our pools to keep us all occupied for those hot summer afternoons. Did you know that phenol red was also used as an estrogen mimic?